Hello and welcome to PE Academy. So as we are gradually rounding up on electric field intensity, so let's just talk briefly about charges with density. So that's the infinite line charge and then the phase charge. So you're just going to be looking at it in terms of the formula. So when you are looking at the infinite, so the infinite line charge, so that's giving us that's the charge density over 2 pi E naught and then r, which is the distance, multiplied by the vector component. Okay, so when you are using this is more like for the cylindrical coordinates. So now we just want to look at one example using this formula. So now this is the example here. It says a uniform charge infinite. Okay, I think a uniform charge infinite with the density. The charge density is 20 nanocentimeter per meter. Sorry, coulombs per meter, not centimeter per meter. Lies along the z-axis. So we are asked to find E at this point. Okay, so let's just go through this. So for in cylindrical coordinates, our r, remember this is the formula. So our r will be root 6 square plus 8 square, and if you should do this, you are going to be getting square root of 36 plus 64. So that's square root of 100, and that will just give us 10. So that's 10 meter. So, and the question says if it lies along the z-axis. So since it lies along the z-axis, so that means our E will be 20 times 10 raised to the power minus 9, which is this, over 2 times. So you can decide to use for the E naught. So for the E naught, which is 8.854 times 10 raised to the power minus 12. So we put it here, 8.854 times 10 raised to the power minus 12, then times 10. So this 10 here. Alright, so if we should put this together, we're going to be getting the answer to be 36 points. So just add the unit vector V over M, and this would be our answer to this question. Okay, so that's for infinite line charge. So now let's quickly look at the plane charge. I think it should be plane charge, not phase charge. Okay, so for the plane charge, so the formula for it in terms of calculating the intensity is giving us the charge density over 2 multiplied by E naught, and then that's in the vector form there, and you had the phase, the unit vector. So this is just the formula you're going to apply if you are dealing with a plane charge in terms of the density. So that's charge with density. Okay, so I hope you find value in this. So that's just what I want to cover under charges with density. Alright, so thank you very much, and I'll see you all in another video.